In electronics development, many basic tools come and go. Some of these are very elaborate, require extensive training, or have high cost. But for people who are just getting started, or for others pivoting from one subfield to another, you've got a few staples that are just too important to pass up. Today, we will look at some of the essentials. Welcome to Unboxing Tomorrow, where we discuss electronics, robotics, IoT, and communication systems. To keep this brief, today we'll focus on small signal applications, and I'll just loosely define that for now as being anything that involves 0 to 50 volts absolute. But even for higher voltages, your starting point is probably a digital multimeter, also called a DMM. It's an obvious first choice, but what isn't so obvious is the set of limits and safety restrictions that are just going to vary from model to model. The best options are going to include safety ratings, i.e. CAT ratings, and as much as we hate to read manuals sometimes, this is the first thing you should review before trying to measure large voltages. But these days, even the inexpensive meters have other secondary features like capacitor measurement, pulse counting, and diode verification that you should know about if you want to get your money's worth. Our next item is the Solderless Breadboard, the operative word being solderless, in that it gives us a way to not only connect things but also hold them together. The typical pitch, or spacing between holes, is 2.54 millimeters, which means it can accept a wide variety of small components. Now, as useful as these are, they are restricted to the amount of electric current they can carry without damage. What that exact limit is varies by the manufacturer, and even the tougher units do have parasitic capacitance that will begin to weaken signals that are over a few hundred megahertz. With that in mind, new high-speed models are being developed, which is bound to keep them relevant for a long time. And speaking of soldering, the next item is the soldering iron itself. Even though most electronics these days are the result of automated production, soldering irons and stations are still pretty much indispensable when it comes to prototyping, testing, rework, and repair. The soldering tips frequently need to be rejuvenated with soldering flux, which might be encapsulated inside the solder itself or a separate product. It is also important to know what types of solder are appropriate for the type of work and materials that you're trying to work with. But with so many variations, this is pretty much a topic for another day. The next item is the Breakout Board. Again, there are many variations on this, but the basic idea is always the same, taking a device footprint that's difficult to work with and converting it to one that's easy to work with. The 2.54mm pitch that I mentioned earlier is common on breakout boards, but you can find many other options, including land grid arrays and ball grid arrays that have no exposed pins. Just be sure that you get the package name right, something I recently covered in my Lessons Learned series on Patreon. The next category, analog multimeters, is a variation on the first. Despite being a low-tech version of its digital counterpart, the analog pointer has just a few properties that a digital display is going to have a hard time matching. For one, analog tends to be considerably cheaper. Secondly, they're a little bit better at conveying visually the scale and rate of change of a random moving signal. This simply works well with human vision and is easier to grasp than a cluster of fast-moving digits. Finally, unless you're measuring something like resistance, they require no batteries. But for signals that are fast-moving, you're better off with our next item, the oscilloscope. Because these have mostly gone digital since the turn of the century, they also contain secondary functions like the ability to record, annotate, or analyze a signal or its fast Fourier transform. Multiple signals can be added, subtracted, or multiplied, and basic characteristics, such as peak voltage, are also available in real time. In this blog, we often work with embedded systems, and the built-in trigger functions are very good for capturing events. Just be mindful of the limits of your input ports and their characteristic impedance. Using the wrong cable or adapter can distort your readings at the very least, or damage your oscilloscope at the very worst. Our next item, the signal generator, is a close counterpart of the oscilloscope. The most basic models can generate common repeating waveforms, and slightly more advanced ones let you create a signal of your own design. These are arbitrary waveform generators, and like the oscilloscope, you want to be mindful of the cabling impedance and even the load. The next category is the protocol analyzer. These aren't terribly far off from oscilloscopes, and in fact, many scopes have these built in. For signals and communication, these devices remove the painstaking process of converting zeros, ones, marks, spaces, and other symbols into frames. They support common formats such as I2C, SPI-Bus, UART, CAN bus, and many others. And in a pinch, you can simply take a low-cost microcontroller and make your own analyzer from scratch. The next item shouldn't need any introduction here, but that would be the low-cost software-defined radio. I've covered these extensively in the past, and with a good antenna and appropriate software, you can decode anything from simple AM radio to digital, trunked, and potentially even encrypted radio streams. The laws for doing this vary by location, so always check the laws in your area before trying to receive anything. Because all the signal processing is carried out by software on a host computer, the possibilities are really endless. And beyond basic data and voice communications, an SDR can do anything from the basic work of a spectrum analyzer or a radio telescope. And last but not least, we have the single board computer. These have gained in massive popularity since the early 2000s, and so far I've covered devices ranging from 8-bit microcontrollers running at 1 MHz to multi-core systems able to deal with real-time operating systems and even neural networks. In recent years, we're also seeing these devices ruggedized for use in Industry 4.0 and mobile debugging. Increasingly, these SBCs even have cloud connectivity and over-the-air reprogramming. SBCs are a recurring theme here, so if you found this useful, be sure to like and share this video. This lets me know what people are interested in, and it helps the channel in general. And while you're at it, consider joining us on Patreon. The Patreon poll for September 2020 wants to know if you use anti-static countermeasures to protect your electrical components, something I covered in a recent video, so be sure to check that one out as well, and as always, have a great day.